So these are the three equations for kinematics of vibrational motion. The first being position, the second being velocity in the x direction, the third being acceleration in the x direction. I want to go through an example problem. It is 19.2 on page 703 in the book. Example 19.2, describing the motion of two objects, is on page 703. It says this, and of course the pictures are in the... The graphical descriptions of the vibrational motions of two objects are shown in the figure. Write mathematical descriptions or equations from these motions. And if you remember these from math, you would notice that the first one is a sine wave, and the second one is a cosine wave, depending on where your 0 point is. So your first equation, just looking at what we can figure out from it, well, it's got an amplitude of 0.2 meters, because it goes all the way up to here and down to there. So 0.2 meters from the middle. The other thing we can see is the period. So by the time it goes up, down, up, right to here, it's made a full period. So it's got a period of 8 seconds. The equation that we're given for position, x equals amplitude sine 2 pi over period multiplied by time. So we can describe this with an equation just plugging in the values that we can see. We can say 0.2 for our amplitude. We can put sine 2 pi. Our period is going to be 8 seconds. Wait a second. Why do I have full 8? Well, it's not 0.8 seconds. I don't know why I did that. It's a full 8 seconds. 8 seconds. Right in the movie. I dare you not to cry. The movie 8 seconds. For the second one, it's going to be slightly different for a couple of reasons. We've got different numbers to deal with. Also, it is a cosine curve instead of a sine curve. If we had shifted it, did a phase shift, we could have it as a sine curve, but as it sits right now, it's not. So to go down, then up, then
It's not possible, but
down.
it's possible to get uncomfortably close.
That would be a period. So our amplitude, 0.4 meters. Our period, and this is why I had 0.8 before. I was thinking of point something, 0.6 seconds. So this is a smaller period, a higher frequency wave, or higher frequency, yeah, I guess wave would work. Similar equation, except for cosine. So plugging in our values, x equals 0.4 meters for our amplitude. Cosine 2 pi over our period of 0.6 seconds multiplied by time. And that is just how we would describe this wave algebraically. Example 19.3 on page 704 says equation jeopardy. There's going to be some problems like this where you're given an equation, and just by giving the equation, you have to figure out all the information from it. Just like Jeopardy, you're given the answer, and you have to figure out the question. It's backwards. You're given the equation, you have to figure out the situation. Instead of what you usually have to do is give it a situation and make an equation. So here's our equation. X equals 0.050 meters cosine of 12 seconds inverse. It's supposed to be s to the negative first multiplied by time. And the question is, what can you determine about this motion? Well, we can relate this to what we were given as far as an equation for harmonic motion, simple harmonic motion, or just vibrational motion, where x is equal to a cosine of 2 pi over period multiplied by time. Given this information, we can start to plug a couple things in. We can see that this 0.050 meters must be our amplitude. And our period would have to be equivalent to 12 seconds. So for this to work, our 2 pi over period is going to have to be equal to 12 seconds inverse, or hertz. If we were to solve this for t, we end up essentially switching spots. That our period is 2 pi over 12 seconds. Well, if it's 2 pi over 12 seconds, that 2 over 12, that doesn't look very neat. We should do it pi over 6 seconds. That would be our period. And if we wanted to know more about this, we could also say, what would the frequency be? Well, frequency is just inverse of period. So if this is the period, then the frequency would be 6 over pi. And the seconds would be inverted as well. Seconds to the negative first. That would be our frequency. Or we could even say, oh man, that's an interesting number. Okay, 6 over pi hertz would be our frequency. So far from this equation, we know the amplitude, we know the period, and we know the frequency. Using other equations, we can find out the velocity of the wave. We can find out acceleration of the wave. Well, velocity in the x direction was negative 2 pi over the period times amplitude sine 2 pi over period multiplied by t. So we can do stuff with that. Our period, we said earlier, was pi over 6 seconds. So 2 pi over 6 seconds is going to be that portion of our equation. The amplitude we know is 0.050 meters times sine of 2 pi over period again, so pi over 6 seconds multiplied by time. This looks kind of sloppy, but there's lots of stuff that can cancel. There's pi's that can cancel a few places, there and there. 2 over 6 seconds, or 2 divided by 6 seconds, so negative would be a third. Take that times 0.050 inches, we end up with negative 0.60 meters per second. My mistake. It would be 2 over 1 over 6. If you bring the 6 up to the top, it'd be 2 times 6, which is 12. 12 times 0.050 would give you this number, negative 0.60 meters per second. As far as all the sine stuff, a similar thing happens. Cancel, cancel. 2 over something over 6. That's like having the 6 on the top. So times the sine of 12, and then seconds inverse, because it was on the bottom, multiplied by t. So that's our velocity without, it would be our velocity at specific time periods. If we had a specific time period, we could put in a value for t, and we could find out the exact velocity at that time. We will get a more exact number for acceleration. I shouldn't say more exact, but similar. Acceleration is negative 2 pi over period, and that whole thing squared, times amplitude cosine 2 pi over t multiplied times t. That's kind of a big nasty equation as well. The things that we can sub in, we know our period, 2 pi over, period was pi over 6, and that was seconds. That whole thing has to be squared, times our amplitude, multiplied by, in this case, cosine, 2 pi over our period, which is pi over 6 seconds, multiplied by time. Again, these will cancel. The 6 will come up, so we'd be at negative 12 squared. So that'd be negative 144 times 0.050 meters. That puts us at negative 7.2 meters per second squared. Times cosine of, these cancel, bring that up top, 2 times 6 is 12. 12 seconds to the negative first, or hertz, multiplied by time. So what does all this really mean? Well, what we can tell from this is our maximum velocity is going to be 0.6 meters per second. And that would be the, I should say, that would be the amplitude of the velocity, or the maximum speed. The amplitude of the acceleration, or the maximum acceleration, would be this. Now that would change depending on where you're at in the wave or you're at in the cycle. It could be positive or negative depending on what you're establishing as up and what you're establishing as down.